In today's Daily Dose of Math, we are doing an example of a task for the Math 4151 Algebraic Modeling course. The task is one of the big questions where they expect you to use several techniques in order to put them together and answer a question. In this task, we are told f of x and g of x intersect at a point that is also on the quadratic function h of x. What value does h of 5 have? The first thing to point out is that this question is being asked using functions language and functions notation. So you have to be familiar with that in order to understand the question. So there is an unknown quadratic function. It's called h of x. If I knew its equation, all I would have to do is plug x equals 5 into that equation, and I would be able to answer the final question. That would be really fast, but I'm not there yet. This is a task. I have to do some work to get to the point of being able to plug x equals 5 into an equation. The functions notation makes it clear to me that I don't need to know what value is produced by f of 5 or g of 5. I don't have to plug x equals 5 into either of those functions because that's not what they're asking for. In fact, for g of 5 is 104. I already have that given. So where do I start? Where I want to start right now is I want to draw a graph because none was given. So I draw a graph. It helps me to see the situation a little better and understand the question a little better. This question didn't tell me what type of curve f of x or g of x are. We know h of x is quadratic, so we can picture what type of shape it's going to have. But these two, we don't know anything for sure yet. So drawing a graph is going to help us to see what type of curve we're dealing with. I'm going to create a coordinate plane. And I'm going to scale so that all of these points will fit. For the x's, I only have numbers between 0 and 6. So I have to make sure that those will fit. I'll put 6 here, I'll put 3 here, and I'll also show -3 and -6. So I've scaled my x-axis and put enough information so that someone can read that. For the y's, my numbers range all the way between -72 and 104. I think I'm going to avoid showing the last point from each of these tables so that I can make my scaling fit between -40 and 80 instead. It'll be a little easier to get everything on the graph, and it will make the curves show up a little larger. So I'm going to go up to 100, and I'll also show 50, as well as -50 and -100. Now enough of these points will fit so that I can draw my curves and get an idea of what the graph will look like. 0.24 is going to be here. To -8 is going to be about here. I'll make my dots a little bigger. And 4 -40 is going to be here. Now this is starting to look quite linear. But I don't consider myself certain that it's linear. I'm going to draw a straight line through it, but I'm going to be open to the idea that it actually could be some other type of function. There's my f of x. Now I'll graph g of x. 232 is going to be about here. 356 will be here. And 480 is going to be about here. And this one also looks quite linear. So I'm drawing a straight line through it, and again, I'm not jumping to the conclusion that I have absolute proof that this is a linear function. There's my g of x. we have to get into h of x. Now, we don't have very much information about the quadratic function h of x. But in this course, we only deal with functions of the form h of x equals ax squared. And those always have the point 0, 0 on them. They always go through the origin. So I'm showing that. The only other thing I know about this for sure is that h of x has the same point on it that is the point of intersection of f of x and g of x. That's here. So this point is on my quadratic. That tells me quite a lot though, because it shows that my a has to be positive and the quadratic function will open upwards. I don't have enough information to draw this well, but I can draw a parabola through those points, and I'm really not sure if I'm putting the rest of this curve in the right place. Not a very well drawn parabola, but I'm visualizing the problem a little better now, and that's the value of doing a graph. I'm analyzing the situation, but I'm giving myself more tools to work with. Now, what should I do next? I need to know that point of intersection, because besides 0, 0 being on this parabola, the only other point I know for sure is on that curve is this point of intersection. So if I can find the point of intersection of f of x and g of x, I'm going to know a point that I can then plug into this and figure out my a, figure out my equation, and then I'm only one step away from the final answer to the question. So, what should I do with f of x and g of x next? What I want to do is I want to test them to see if they are linear, quadratic, or exponential, because I want to justify what I'm doing. I think they're linear, but I want to justify that, and the test will justify it. So I'm doing the constant difference test. I'll do it down here. Negative 8 minus 24 equals negative 32. Negative 40 minus negative 8 is also equal to negative 32. I'm starting to think that this is linear because I'm getting a constant difference. Negative 72 minus negative 40 equals negative 32. This is linear. Doing the same test for g of x, 56 minus 32 is equal to 24. 80 minus 56 is equal to 24. 104 minus 80 equals 24. I have a constant difference and proof that this is also linear. Now I'm showing whoever's correcting my question how I know they're linear in order for it to make sense that I'm going to do the next step. And the next step is to find the point of intersection, which I know I can do with comparison. So I say I'm doing comparison, and I need equations. I have to do the equations before I can do the comparison. I'm wrong. The comparison is not the next step. What I have to do is find the equations for f of x and g of x. I'm going to start with the slope formula because this is linear. So, for f of x, negative 8 minus 24 over 2 minus 0 gives me negative 32 over 2, which is negative 16. I have an equation that is y equals negative 16x plus b. But the b is given. I'm lucky. They gave me the point where x equals 0, so my equation is y equals negative 16x plus 24. So I'm writing something that I'd really like to see a student write if they're doing this on an exam. Instead of just pulling that b and writing it down without explaining what you're doing, 0.24 is on the line, so it's a way of expressing that I know the y-intercept, therefore I know my b. So we have an equation for f of x, and I'll write it here. F of x equals negative 16x plus 24. And I'm doing that because I need to erase. Now, of course, a student doing an exam isn't going to erase. They're going to leave everything for the teacher to see who's correcting, but I'm limited with space here. So I'm removing this now, but I'm reminded here of the resulting equation. Let's do g of x. 56 minus 32 over 3 minus 2 is equal to 24 over 1, or 24. I have y equals 24x plus b. I don't have the point where x equals 0, so I'm going to plug in another point. I'll choose 4 and 80. 80 equals 24 times 4 plus b. 80 equals 96 plus b. So b is equal to 80 minus 96, which is negative 16. My equation for g of x equals 24x minus 16. Interesting, the 16s and 24s are being used here, but that doesn't matter. What matters is I have equations that I can now use in my comparison. Negative 16x plus 24 must be equal to 24x minus 16 at that point of intersection. Therefore, 24 plus 16 is equal to 24x plus 16x. 40 equals 40x. X is therefore equal to 1. I have the x coordinate of my point of intersection, 1. Let's find the y coordinate. Using f of x, y is equal to negative 16 times 1 plus 24, which is negative 16 plus 24, which is positive 8. Y is equal to 8. Now remember, I keep erasing things, but a student shouldn't be erasing all of these things. These are all necessary steps in your process. You need to show the whole process. Justify everything you do as much as possible. It's a good idea to say, I'm using the slope formula before you do the slope formula, instead of expecting the corrector to figure out that's what you're doing. But now I know the point 1, 8 is on both f of x and g of x, but more importantly to me right now is also on h of x, because it says so here. So I can plug 1, 8 into h of x in order to find the equation. So I get 8 equals a times 1 squared. 1 squared is equal to 1. So 8 equals a. I know my equation. H of x equals 8x squared. Final answer is coming up. If h is 5, h of 5, notice again that I'm using functions notation here, is equal to 8 times 5 squared, which is 8 times 25, which is 200. I have my final answer. In a way, it feels easy, maybe too easy, because when you first look at the question and you haven't got any of the answer down, it looks like a big, long, confusing process, and it's intimidating. But each of the steps that I've done, the graphing, the tests, the slope formulas and other work to find the linear equations, the comparison, and deriving the quadratic equation, plugging x equals 5 into it. Each of those steps by itself is a small thing which I have practiced a lot. If I'm ready for this exam, I know how to do all of those little tricks. Now that I've done them one at a time, I'm only focusing on one at a time. And I feel less confused, less overwhelmed, less intimidated. But now I get all the way to the end of the process, and I managed to piece together all the steps I needed in order to answer that question. I'll make one other point. If this is really a task questions tend to be in a situation. I didn't bother creating a situation here. This is a very, very math style question. I'm not explaining what f of x represents in real life, or g of x, or h of x. A task would usually do that, and one of the ways that makes a difference is it allows the student to give their final answer in the form of a sentence, explaining not only that h of 5 is equal to 200, but what that means in the context of the situation. It also allows the student to apply a unit of measure. But the underlying math is the same. That is today's Daily Dose of Math. Please like, subscribe, and share.